Welcome to the lecture on comparison of alternatives. We will discuss about different methods. We have anyway so far discussed about the methods like present worth criterion, future worth criterion and annual equivalent criterion. The fourth one which is important is internal rate of return. So, we have already discussed about it that the internal rate of return is that rate of interest at which equivalent value of receipts is equal to equivalent value of disbursements. So, basically at this rate of interest your present worth value will be equal to 0 for any investment. So, this is how the internal rate of return is calculated. So, what we see is if you have f t as the cash flow at any time t, then we know that the present worth expression is nothing but summation of t equal to 0 to n f t into 1 plus I raised to the power minus t. So, the value of I, that is I star, this I star for this value basically if you calculate the present worth value it is 0. So, this I star for which present worth is 0, it is known as the internal rate of return. Let us see by an example that this is a cash flow diagram and which tells that in the year end of 0 you have a disbursement of 10,000 rupees, in the year end 1 you have disbursement of 8,000 rupees, then from 2 to 4 there is receipt of 5,000 rupees and there is receipt of 12,000 rupees in the year end 5. Now, we have to calculate what is the internal rate of return for this particular investment. Now, let us see how to calculate the internal rate of return for this particular cash flow. As we have discussed that PW I star should be equal to 0. So, if we try to draw the cash flow diagram for this series, we have 1, 2, 3, 4 and 5. So, in the 0 year we have disbursement of minus 10,000, then we have disbursement of 8,000 in the first year end, we have 5,000 each during the second, third and fourth year, and we have this receipt of 12,000 in the fifth year. Now, for this, as the condition tells that the present worth investment should be 0 for that particular interest rate and that particular interest rate will be internal rate of return. So, if we try to find the present worth for the rate of return, that is I star, this will be nothing but minus 10,000, because we are basically finding the equivalent value of this at this time itself. Then we will have 8,000 multiplied by P by F I star 1. Then we have 5,000 P by A I star 3, which will be basically defined at this particular point, and this will be further multiplied at this with the factor P by F I 1. So, P by F I star 1, because once we have got the equivalent value of these three cash flows using P by A diagram interest factor, this will be defined at this particular time. So, from here again we have to multiply with P by F I1, and that will give us the equivalent value at this time. Then we have 12,000 multiplied by P by F I star 5. So, basically the internal rate of return will be that percentage of interest for which this value should be 0. So, we have to equate it to 0. So, this is solved by trial and error methods. Now, using the trial and error methods, we will find PWI. If we take using trial and error method, so let us start with the rate of interest as 0. So, if I star is taken as 0, in that case present worth for 0% interest will be nothing but minus 10,000 minus 8,000, because this will be, since there is 0% interest, so this will all be 1 plus all these 3. In that case we will have, since it is 0% interest, we will have these values. So, 5,000 P by A 03 will be 3, and this will be 1 again, plus this will be again 1, so 12,000. So, 12 plus 15, 27,000 minus 18,000, and it is equal to 9,000. As we go on increasing the value of I, this PWI goes on increasing. Let us see, we can check the value of present worth at 5% interest. When I star is 5, for that what we have? Minus 10,000 minus 8,000 P by F 5,1 plus 5,000 P by A 5,3 multiplied by P by F 5,1 plus 12,000 P by F 5,5. So, we need to have these interest factors, and we can get these factors from the interest table of 5%. So, this is the 5% interest table. P by F 5,1 is 0.9523, excuse me, pardon me, this is 0.9523. Then P by A 5,3 is 2.7232, P by F 5,1 0.9523, P by F 5,5. So, P by F 5,5 will be here 0.7835. So, once we do this computation, we will get minus 10,000 minus 0.9523 multiplied by 8,000. So, this is 7618.4 plus 5000 multiplied by 2.7232 multiplied by 0.9523, this comes out to be 12966.5 plus 12,000 multiplied by 0.7835. So, it comes out to be 9402. So, if we add these all, this comes out to be 4750.1. So, what we see is for the interest rate when it is taken as 5%, the present worth comes out to be 4750.1. So, if we draw basically a curve of present worth value, we have seen the interest rate values at 0, it was coming as 9,000, and then at 5% it has come to a decreased value. Now, this value will decrease continuously and ultimately it has to cross somewhere, and this is the point where it crosses this x axis. This point tells the interest rate value for which the present worth value will be 0, and this will be the internal rate of return. We can further check by taking another interest factor. So, if we take I star as 12%, what we get? We get minus 10,000, minus 8,000, P by F 12.1, plus 5,000, P by 8 12.3, into P by F 12.1 plus 12,000 P by F 12.5. So, basically this term will be a positive value. This we can complete when we solve the problem in the next lecture. Incidentally, when we calculate for 13% interest, this eventually comes out to be a negative value. This indicates that for I star value between 12 and 13%, PWI will be equal to 0, and this I star will be the internal rate of return. So, basically we will solve it in our next tutorial class, when we will solve this finally, and we will see how we can get this I star by using the interpolation methods. So, basically once we have solved this, it has been found that the value of I star is coming out to be 12.8%. So, this is how the internal rate of return is calculated. Now, next method of comparison is capitalized equivalent amount. Many a times it has been seen that basically the type of cash flow is perpetual, means it goes for a very long period. So, sometimes we need to have a deposit so that certain amount you can get for the whole of the life or for a very large duration, means in these cases the n is tending towards infinity. So, basically it is a special case of present worth basis of comparison. It is useful when the life of proposed project is perpetual, and it represents a basis of comparison in which single amount at present time will be found. So, basically your job is to find the present worth at present time at a given rate of interest, so that this amount should be equivalent to net difference of receipts and disbursements when cash flow pattern is repeated in perpetuity. So, basically you see that certain cash flow diagram is going forever or continuously. For an example, when we construct a bridge, the bridge is to be maintained in course of time. Now, in that you need a fund from where you can get certain amount for the maintenance purpose of this bridge, and that may be required for years continuously, maybe 50 or 100 or so. So, basically you need a fund, and that is known as a capitalized amount or capitalized equivalent amount. So, it means the cash flow in this case is basically converted into the equivalent cash flow of equal amounts, and basically this equal amount has to go for infinity. So, it is same as present worth equivalent when n is approaching towards infinity. So, basically it is the present worth amount for which you are getting certain equal annual payment, but n is moving towards infinity. That is why it is written capitalized equivalent I at interest rate I is nothing but it is the present worth value when cash flow extends forever. So, n is moving towards infinity. So, you can write as CEI as A times P by A I n. Now, what you see is capitalized equivalent at rate of interest I, it is nothing but the present worth. You need a P which will give you certain A forever. So, n is infinity. So, you need this present amount, the equivalent present worth when n is moving towards infinity. So, once you know the A can be multiplied with P by A I n. And n is tending towards infinity. You need certain equal annual payment that has to continue forever, what we see here. So, this A, its present worth equivalent will be A times P by A I n, and n is moving towards or approaching towards infinity. So, you can write A into, as we know, P by A I n. So, it is nothing but and This is the case when n is approaching towards infinity. So, we can write as a times limit n tends to infinity 1 plus I n minus 1 upon I into 1 plus I n. So, it can further be written as a times limit n tends to infinity 1 plus I n upon I into 1 plus I n minus limit n tends to infinity 1 upon I into 1 plus I n. So, as n tends to infinity, this will vanish, and here this and this term will be cancelled. So, you get 1 by I. So, a times 1 by I, that is a by I. So, capitalized equivalent amount is nothing but the annual equivalent amount by I. So, this is how the capitalized equivalent amount is calculated. Now, if we look towards its meaning, it is nothing but the investment or an initial deposit which will earn certain interest, and this interest amount will be given to you forever. So, A is nothing but P times I. So, basically it is that amount which is the interest earned on certain deposit, and you are likely to get it forever. So, it is known as capitalized equivalent amount. Next is capital recovery with return. Now, capital recovery with return, it is under those cases where you have two types of expenditures, capital expenditures. One is the initial cost of the asset, and the another type of cost is the return on this asset when you are disposing it at the end of its life. So, at the end of its life, what you are getting is known as the salvage value. So, basically this is known as CRI. So, it is represented by the term CRI at particular I rate of interest. For any investment is the equal annual cash flow over its life, that is equivalent to capital costs of the investment. So, capital cost involves the initial cost and also the return you get after selling the final asset, and you get the salvage value of it. So, capital cost includes initial outlay and the final salvage value. So, you have two transactions involved, first cost and the salvage value of the asset. So, let us see how the cash flow diagram is represented in the case of capital recovery with return. So, what we see is, in this case your the cash flow diagram is this. You are investing certain amount now, and at the end this is your salvage value. So, initially you have put in this amount, and this is the final salvage value which you get it while selling all the property which you had. This is known as the final salvage value. So, this is basically the equivalent annual amount. So, capital recovery with return is the basically the equal annual payment which is corresponding to the equivalent of this cash flow. So, you can say for this the equivalent annual cash flow will be P times A by P I n, because once you multiply this P with factor A by P I n, it will tell you certain A, which is basically a disbursement. Then this F also multiplied with A by F I n will give you certain annual equivalent value. So, this is to be subtracted with A by F I n. Now, as we see that A by F I n is nothing but A by P I n minus I. So, it comes out as P minus F A by P I n plus F times I. So, this way we can calculate the capital recovery with return, where you have initial outlay as well as the final salvage value, and this formula is used for finding the capital recovery with return. This is how these equivalent values are calculated. We will discuss about the problems in the next lecture to come. Thank you.